Okay, we will start this new course on electromechanical systems from today, and the name appears special because it is named as a special electromechanical systems. Okay. Now, this must be something special, that means which is other than what you have studied in other courses on electrical machines. Okay. Invariably, the conventional courses on electrical machines deal with conventional machines. Okay. And what are the conventional machines? The conventional machines are those who have been used for a long time, which has fairly mature technologies and which find quite widespread applications, mainly in industry. And these are typically the traditional DC machines, which have been in use for over a century or more, ever since the first machines, electric machines were invented. Then came the AC machines, which are typically synchronous and induction machines, and they are also been well established technologies and use. Now, these have been well covered in your earlier courses, and also they have been used. Okay. But again, over the development of the subject since last maybe 30-40 years, apart from this, some new machines have been evolving. Okay. And because of the new applications and new needs, and these new machines are also evolving continuously. Okay. If we find that some new machine has come to replace an old machine, that means the old machine will give way to the new machine, right. So, there have also been historically some special machines which were used, but which are now not in use. Okay. So, for example, there was a time where the AC commutator motors were very much in use, or the Schrage motors, etc. But now they are no longer in use, right, because some new systems have come for a variable speed operations. Therefore, they have given way, so they can now at best be kept in a museum. Okay. Now, similarly, there was a time there were special generators and motors used in railways, railway generators, etc. Okay. There were also repulsion motors and so on. Again, they have now not been in use, right, and some new machines have come to the picture. Obviously, this course will not be concentrating on those machines which have become obsolete, but will be dealing with only new ones which are now in use or likely to be in use in future. Okay. So, this is a continuous evolution of electromechanical energy converters, right. So, we will be dealing with this subject in this course, which will span for more than 30 lectures or so. Okay. Now, this is just basically my details, okay, and my email details are here, and I have my website. I hope to include the course materials, upload it in the website, right, and also a e-group has also been formed for this course, and I expect all of you to be enrolled as the members of this group. So, it will be we will try to see that as much information is available to you as possible. So, it is not only that I will be uploading, but each one of you will also be uploading any new information that you have. So, so that this e group becomes a more an interactive group, right. And as I mentioned that we will have volunteers. So, each of the lectures will be notes will be prepared by one student. Okay. So, today's lecture will be prepared by one student, and similarly every other lecture. And I would expect that in that week itself that lecture has to be uploaded to this group. Okay. Right, that is the thing. So, there is a deadline for this. So, deadline is the same week, that means before Sunday, that should be visible in the e group. Let us maintain this discipline. Okay. Right. Now, as I mentioned, this name special electromechanical systems, right. This name is there for this course. Now, we have to understand what are these, what type of creatures are they, what are these materials or machines or whatever, why do we call them so. Okay. Now, we call them as special, right. Why do we call them as special? The special, is they are not conventional. Okay. That is why they are not traditional. Okay. And they are not in typically in a very continuous use, right. So, that is why you call them as special. Okay. And they are normally invariably of a low power ratings, right. And I hope there is an English meaning of the term conventional. I have mentioned in some places when anything has been continuously in use, you take it as conventional. See? Maybe there was a time where most of the Indians were wearing dhoti or something, it was conventional, and the pant became trousers. So, it became modern in a way, okay. Right. And now, so that will become perhaps now special, because majority of the people will not be using that, will be using the so called recent dresses. Okay. Therefore, there was a time where sari was very traditional once upon. Now, today it has become modern, because very few people wear that. Okay. So, there are all we have a convention. Therefore, in any dynamic system, what falls under a traditional, what falls under non-traditional or special will be decided by practices. Okay. Same thing happens with these special electromechanical systems, right. Now, we call this as electromechanical because these are basically energy converters, which we often call as electrical machines. So, we are dealing with electromechanical energy converters or the electrical machines, and historically by the work of Faraday, Tesla, Edison and various people, these subjects got developed for over 100 years, right, or 150 years you can say, and they have been in development, right. Next is we call it as systems. I mean, other than calling as special electrical machines, you also call them as systems, because these often may not work just as a machine, but with other accessories. So, it is machines with associated accessories, right. So, you will have the supply This is one thing. So, supply will be either a single phase supply or a 3 phase supply. Today these are the well known supply system. Even a DC comes of an AC supply through a rectifier. Okay. So, ultimately at the front end of any of such systems will be a AC supply of a fixed voltage, fixed frequency. Okay. Then you control that. There are also controllers for this that will be included in the system. Okay. And there will also be converters which convert the signals or convert the power, right, from AC to DC, DC to AC, DC to pulses and so on. So, these are all converters and they are all coming out of the developments in power electronics. Okay. It is the power electronics which converts, right, from one type of voltages and currents into another type. Okay. And there may also be nowadays softwares are available. You can do a lot of programming on like DSP or microcontrollers and so on, so that you can have programmed control is possible, and also this may include sensors. So, a system, this special electromechanical system will be a combination of these, right. Is it clear? Therefore, we can always say that if you have a machine okay, let us see. Now, this is the machine and there will be a supply. Okay. Now, this supply to the machine, you may have some in between, you can have a controller. Okay. So, you have this, so there is a supply, a controller and a machine will be there, and sometimes you can also have another box here which can also take signals from this and also operate on the controller. So, this may be some feedback system. Is it clear? So, it may sense the signals like maybe a speed signal it can sense, current signal it may sense, okay. All this will be there, okay. And of course, the machine typically there may be a load on the machine also. So, this whole thing you can call it as a system. Is it clear? For example, if you take like a, okay, I will take a ceiling fan. So, what will happen? So, there is a ceiling fan, right, which is driven by a motor. Say which is supposed to give you the nice air. And there is a supply which may be single phase 50 hertz, say 220 volts supply. So, this is available. Okay. Then you take this supply and in between you have a regulator. Okay, which will go to the motor, right. So, this is one system which is basically an open loop system, isn't it? There is no feedback in a way, it will not automatically control, but there are many systems where there is a feedback also, like air conditioners. Air conditioner you set the temperature, so there is a thermostat. So, when the temperature is reached to that desired value, that motor will stop, okay. Or a compressor in a refrigerator, again you set a temperature inside the container of the refrigerator, and when that temperature is achieved, then the motor will stop, motor will not drive the compressor, right. So, there are here the only feedback is from the human, you become a part of the feedback, a human being, okay. So, when once you feel cold, you will switch it off automatically, okay. Now, I am just giving an example, a system, this is just a motor and the system, okay. Now, we have to understand what type of motor to be used for what application, what is the best way to do it, okay. So, it is not the same motor you use for all applications, isn't it. So, there are different motors for different applications. So, this course will center around studying the construction, behavior, operation, analysis, design, applications of each of these motors, each of these machines. So, that will be the broad canvas of this course, okay. So, we will be discussing here with machines generally which are other than the traditional machines, okay. So, we will be generally discussing other than conventional DC machine, other than conventional synchronous machine and other than conventional induction machine. We may be discussing say induction machines, but then we will not be discussing the conventional type, we may still discuss. We may discuss synchronous machines which are not conventional type, we may discuss DC machine which are not conventional type. You see conventional one may be wound field machines, but here you may look at permanent magnet machines which are not conventional, okay. You may have synchronous machines, but you may consider permanent magnet synchronous machines. You may have induction machines of a special application, it may be self excited machine, okay, and this thing, right, and doubly fed ones and so on, right. So, we will be concentrating on these type of machines which are may be classified in the same categories, but they will not be another, but we will also discuss other machines also. So, we will be discussing the non-conventional aspects of the conventional machines as well as the special machines other than these machines, okay. Therefore, what we will be broadly covering, okay, will be the special, first we will discuss about the special operation of induction machines. We studied induction machines, but they will be special operation like a single phase induction motor. So, single phase induction motor is a special type of a 3 phase induction motor, okay, which operates, but basic principle will be same, okay. We will also discuss permanent magnet machines. Again permanent magnet machines are going to be one of the important machines for the future. Therefore, they have been very widely used even nowadays, okay. So, we will be using, and permanent magnet can be DC machine and permanent magnet AC machines, okay. Only thing, what is permanent magnet machine compared to the other machines is that it will replace the conventional electromagnet, right. So, what electromagnet does is you make a pole and put a coil over it and pass a DC current into it through some way, and it creates a magnet. In a permanent magnet you remove that whole electromagnetic structure and put a magnet which has a fixed field it will produce. What is the difference here compared to the other electromagnet? What is the difference? What is the main difference electromagnet and permanent magnet? Yeah, field is constant, you can't control the field as much as you can control in a electromagnet. You can control the DC current, then it will automatically change the flux or the flux density, but permanent magnet you can't. So, we have to study the whole principle of a permanent magnet, okay. And also if you must also understand that permanent magnet is not just like what you have it in the toys, you must have done in a physics experiment. You have put a magnet on a table and put some iron pieces over there and creates, and you seem to understand everything about permanent magnet. It is not so simple. Okay. So, it is the different materials, how they operate, and again permanent magnet is almost like a battery, right, and what is the current from a battery differs from what you connect to it. So, similarly permanent magnet also, what to connect to the permanent magnet externally, that will be just like for battery you connect a electric circuit, for magnet you connect a magnetic circuit. So, what type of pieces you connect across that. So, that will decide the magnetic field systems and what is the flux it will produce and so on. Therefore, permanent magnet machine study is fairly involved. Okay. So, we need to understand the whole processes involved in this. Then there is another machine which does not have a magnet at all. It is called a switched reluctance machine. Okay. That means it works on the principle of a magnetic reluctance. Okay. You know that whenever you bring an iron piece in terms of a magnet, it experiences a force. Therefore, if you make anything a variable reluctance, right, and any variable reluctance rotor will align itself with the magnetic field produced by the stator. So, by manipulating the magnetic field produced by the stator, you can also manipulate the force and torque experienced by the rotor, which is just an iron piece. So, you have a machine with no field, right, neither electromagnet nor a permanent magnet, but only that is what is produced is in the type of excitation given to the stator. Okay. We will discuss this also when we go to the switched reluctance machine. Then there is the stepper motors. While most of the motors rotate, stepper motor do not rotate, it just moves, okay, moves in steps. So, it is, after all, you can always say that if you make it fast, the fast stepping is also a rotation, right, but it is how you freeze your view. Okay. A smaller, if you increase the frequency, step movement becomes a rotation. Okay. Just like you walk in steps which is visible where you have put the steps, but if you run very fast, it is almost like a rotation. Okay. It is not visible. Okay. So, stepper motors, there are permanent magnet stepper motors, variable reluctance stepper motors. Okay. These are the ones which we will be also discussing as a part of the course, and we will also discuss some other machines which may be which may not strictly come into these categories, or it may be overlapping between any two of the categories and so on. Okay. There are also linear motors, okay, which does not rotate, which moves, okay, your magnetic levitated systems, transportation systems and so on. Okay. So, these are the broadly the ones that we will be discussing. To get into a little more detail, is it clear what broadly what we want to discuss? Now, the special operation of induction machines. So, what special operations that we are looking at? You have a normal 3-phase induction motors. Why the induction motor is still the most sought after exciting one is because it is the cheapest machine per kilowatt produced in the world, right. It is the smallest machine per kilowatt produced in the world, and it has the highest level of automation, and it can be designed more or less. A computerized design is possible, computerized manufacturing is possible. You have the machines which can wind, there are winding machines, okay, automated. You can make the rotor in maybe less than a minute. One rotor, a squirrel cage rotor can be made in less than 1 minute. Okay. So, therefore, there are a lot of advantages of these induction machines, and today they consume 70% of the electricity produced in the world are by induction motors. Okay. Now, what special operation is there? Special operation will be when the voltages across it is not balanced. This is one special operation which is deliberately or non deliberately it happens. Okay. This is one operation that you will be studying. Another is induction, induction machines are asymmetrical operation. Asymmetrical means your windings are not similar, they may not be disposed at 3 phases or it can be 2 phases. Okay. In fact, today people are questioning why only for 3 phases, why not you have higher number of phases. Okay. And if the power electronics can give you multi-phase supplies, why not to go for higher number of phases. So, people have been working on say 5 phase motors. Okay. So, that is also one of the things. Of course, one of the problem is if you have increased the number of phases, complexity also increases, but many times your device rating may come down if it is to be because if you have a 10 kilowatt machine, then if you have more number of phases, power handled by each phase will get reduced. So, the power electronic circuit may be smaller, okay, but device numbers may increase. Okay. So, there are trade offs in each one of them. Okay. So, a conventional single phase motor is also an asymmetrical motor, it will not be 3 phase, it will be 2 phases. Okay. So, they are located at 90 degrees electrical and they are often not symmetrical windings, 2 windings are asymmetrical. Okay. So, that is another problem that you have. Okay. They may not have same number of turns. So, you need to understand how they are actually wound, right. You imagine how the 3 phase machines are wound, how the 2 phase machines are wound. Okay. I think one of the thing all of you should understand, how the actual winding of these machines are important. Okay. And there are different types of windings also. There are concentrating windings, concentric windings, there are overlap windings, diamond shaped windings, there are windings which are rectangular windings. Okay. So, you can have a different types, shapes of windings will also be there. Then nowadays one of the important areas which have become important, induction generators. Okay. That means induction machine operated as a generator, which you normally do not study in your traditional courses, right. And this became important when once the wind energy came to the picture. Okay. So, wind energy started its development for power generation typically in 80s. Okay. In 80s the largest wind machines were about 11 kilowatt. Okay. Then around mid 80s it becomes around 50 kilowatt, 55 kilowatt or so. Then end 80s it became about 100 kilowatt single unit. Okay. As I mentioned, nowadays it has been installed about 1.5 megawatt. Today single unit wind machines are about 1.5 megawatt, and many of the leading multinationals companies like Suzlon, GE, Vestas and so on, they are envisaging to have about 5 megawatt single unit. Okay. And they are large machines, of course many of them may be offshore. Okay. And they may also bring power through the cables through the sea, right, and with large blades. In fact, I was told the size of the blade may be as big as a football field. Okay. So, that is the type of systems we are looking at. And then there is a we have these generators which are mostly fed by wind or even by hydro. You can also have mini hydro plants because there are a lot of hydro potential available. All this have now become important because the conventional energy sources are depleting, okay, like coal, oil, gas. Okay. These are not only depleting, but they have lot of environmental effects, okay, pollution effects. Okay. And also there is also international agreements nowadays called Kyoto Protocol and so on, where you have to control your carbon dioxide emissions and also control your greenhouse gas effects because which is affecting your ozone layers and depletions and so on. Therefore, all this has since it is all threatening the very mankind, okay, therefore, there is more interest in shifting towards those energy systems which are non polluting, renewable and more natural. Therefore, this the wind, hydro, because nowadays nuclear also they say is safer, but again it is a this debate is a perpetual one, right, it goes on. Okay. So, this wind driven or hydro driven induction generator feeding to the grid is a very new technology, and they can be singly excited or doubly excited. Okay. It can be only fed to the grid with a squirrel cage machine, we are singly excited. If you have a slip ring machine, you can make it doubly excited, you can control to the rotor also. Nowadays, that is also one of the areas which is being pursued. Okay. Then another area of our interest is self excited induction generators, where induction generator can be self excited through capacitors. Okay. So, we will study it in detail, because they are now found to have a applications in small hydro, biomass engines, engine driven portable gensets, as well as on wind also to some extent. Okay. So, we look at this. So, there means several aspects of induction machines we will be doing it again, but in a different perspective. Okay. Then of course, we will go for this is another broad area, permanent magnet machines, okay, which will also be covering. That is because we have the permanent magnet materials, and that is one of the things we need to know. What are the materials? Because the latest one with high energy density, earlier there were low energy density ferrites and so on have been in use, but this one of the latest one is neodymium iron boron, one material which has a very high energy density. Okay. So, they are being, so we study what will be the relative character different classifications of machines. What are the types of basic principles, analysis of the machines, operation of the machines, characteristics of these machines, control of these machines, design and application. All these aspects we need to understand as a part of the permanent magnet machines. Okay. And permanent magnet, you can have permanent magnet synchronous machines. So, what is the permanent magnet synchronous machine? They are typically sine wave machines, right. They use sine waves. So, you put it in the rotor magnets. So, you instead of electromagnet what you have in a conventional synchronous machine, you put a permanent magnet. So, rest of the things will be same. So, you can use it as a generator or a motor. So, that will be the permanent magnet synchronous machine, and you do not control anything, it is unlike in a brushless type. Now, there is also permanent magnet DC and permanent magnet brushless DC. Now, again you need to understand what do we mean by this. Now, one is a permanent magnet DC could be a conventional DC machine with commutators, just put magnets instead of the electromagnets in the stator. So, rotor will be same with armature winding with commutator and brushes. So, the old tape recorders, they all be toys, most of the toys they are all using permanent magnet DC machines, but with commutators. Okay. So, they are the conventional one, but you can also make it brushless. How do you make it brushless? Brushless means again you have to invert it. So, you can't have brushless with armature in the rotor, you have to bring armature into the stator. Okay. So, you can have multi-phase multi-pole stator winding, rotor will be the permanent magnet, but you do an electronic commutation in the stator, but you need to, in order to work like a DC machine brushless DC, then you have to sense the rotor position. so that the field produced by the armature is always 90 degrees with the field produced by the rotor. So, that is the main difference between the permanent magnet brushless DC and synchronous machine. Is it clear? So, you have to you have to pass a current in the stator windings in such a way that the field is always at quadrature with the rotor field. Okay. Now, the another important issue here is that this need not be, this can be a square wave also. You need not pass a sinusoidal currents. Okay. It could be trapezoidal or a square wave in brushless. Okay. And of course, you can have a combination of synchronous reluctance or hybrid motors. Okay. These are all permanent magnet, but you can have a reluctance plus PM both thrown in. Okay. Now, one of the latest techniques is you need to understand is the finite element methods for design and analysis. See, FE, I think you must have heard this name, or if you have used it in some other course. The finite element methods have been proven to be very effective numerical techniques for solution of field problems. And what type of fields you have? Here we have a magnetic field, right. So, there could be any field, you know. What is a field? Field is where some elements experience forces. Okay. It could be a thermal modeling, okay, where the heat elements, heat sources, so it spreads the heat flux, okay, one is the magnetic flux, or it could be a fluid mechanics, okay, fluid mechanics also a certain type of a fluid field, okay, or even mechanics where the forces and torques are operating inside the a material, okay, whenever it is subjected to vibrations and so on. So, there also at every point in space you need to know what type of fields are there. Okay. So, and that means you have to solve the respective governing equations. In here typically you solve the well known electromagnetic equations. What are those equations? What are the well known electromagnetic equations? Maxwell's equations. I hope all of you know, have you heard of Maxwell's equations? If you have not heard of, you better study this. Okay. Everybody should know the Maxwell's equation. So, the thing is this will be centered around Maxwell's equations. These will be solved through numerical methods. Okay. So, that is one of the aspects. Nowadays a lot of softwares are available, commercialized, and some are available on open public domain softwares are there. So, one of the things I want all of you is from now onwards start locating these softwares which are available to you and download it in your computers, okay, so that I can give assignments on that. Okay. So, that is there are Maxwell this magnet softwares. Okay. So, they are some companies who are doing it. Then we discuss about switched reluctance machines. So, switched reluctance machine is, as I told you, rotor is not having any fields at all, it is a variable reluctance. So, if you put a purely cylindrical, it will not experience any torque, only if you cut it to proper shapes, then it will experience the torque because of the variable reluctance in the rotor. So, therefore, it must have a special construction of the switched reluctance machine. Then we have to how to analyze these machines. Okay. Then what will be the characteristic of these machines? Because switched reluctance machine, unlike the induction machine, they have lot of torque pulsations. After all, you are not going to have a smooth torque produced, okay. It will be jerking torque, okay, especially if your frequency is low. So, the torque pulsation is an issue. When torque pulsation is a problem, there is a noise. Now, you want most of the machines should be smooth, noiseless, silent, but these are some of the problems. Okay. Then how do you control these machines? After all, you want to switch the currents into different windings in the stator, you have to switch the currents. So, when you want to switch the current, you need a power electronic converter which will go on switching, but you need devices. Okay. And then there are design aspects of the things and where they can be applications. Okay. So, then again there also you may require a finite element methods for design and analysis. Okay. So, these are the aspects which we will be studying. Then another important motors will be stepper motors, which does not work, they work in steps. So, when they work in steps, the supply is not AC or DC, they are invariably pulses. You into the windings you feed pulses, and therefore, when you feed pulses, accordingly the rotor will start moving because to follow the pulses in the stator, right. So, again, so the principle of the stepper motor is the rotor moves in steps, typically for robots and so on, and machine tools and such applications. So, again we need to know its construction, basic principle, operation, control, applications and so on. There again in the rotor you can either have a permanent magnet or you can have a variable reluctance or a combination of these called hybrid stepper motors. Okay. And these also you can analyze through the finite element methods. Okay. So, these are the aspects which you can see. There are books written on stepper motors, the complete book will be there. So, we will be only covering a sample of these things. The purpose of the course is to sensitize you on what are the basic things, so that you can build upon it subsequently. Okay. Then of course, other machines also, like what is a hysteresis motor, is again a synchronous motor. If you have a high hysteresis in the rotor, then it will rotor gets magnetized. Okay. When that means a permanent magnet is created, so that becomes a synchronous motor. So, magnetic hysteresis will create a field in the rotor. This is one of the aspects. There are also what is called disc motors. Disc motors are not conventional motors, they are not cylindrical type. So, they will be like a disc, there are applications where you require a large diameter and a small length. For example, vacuum cleaner. Vacuum cleaner you want a large diameter, it will if it rotates, then maybe it will mop a larger area. Okay. Or a scooter, two-wheeler scooter, if you have a motor which will be like a tire, okay, larger dia and a smaller length. Okay. So, disc motors will invariably have the flux which is not radial. In conventional machines, flux is radial and current is axial, is not it? In normal machines, flux is radial through the air gap, and current is parallel to the shaft. Here it is other way around. You have the flux which is parallel to the shaft, that means you have the magnets pasted on a disc, north pole, south pole, like that in alternatively, okay, and the currents, windings are wound radially. So, on a disc, take a thin disc and it is wound radially. So, this is a disc motor. There are also hub motors, like a hub, and there are linear motors, that means everything which is rotating can be made linear. So, it does not rotate, it moves in a linear fashion. Okay. And of course, there have been lot of work, it is not a very new area per se, but people have worked on it, like one of the person is Cyril Wienet, and his world classic of theory and design of small induction motors is well known. Okay. And he lived for 96 years and expired only recently. Okay. He was an IEEE fellow, and he has written, and also this was earlier book by he was working with Reliance in USA, and it's one of the well known design books. Today almost every manufacturer of all over the world uses his design formula. Okay. So, this is a very good book, all of you should read this. Okay. Then of course, this book is not on design, but basic things of fractional horsepower motors. Of course, it was in 1986 I think, the last one where it was, but he gives a basic working principles, etc. Okay. Of course, then this is a classical book, Fitzroy Kingsley Woman's, and there are few chapters which deal with special machines, you can do that. And Miller is again has been one of the pioneers of in last couple of decades, who has also brought out computer aided design of these machines, and his was a old book by Oxford University Press, both on it consists of both PM and reluctance motor drives. Okay. Then Kenjo Nagamori also is PM and brushless DC motor drives. Okay. Then Miller has written a design on brushless PM motor drives. Okay. So, these are very useful books actually, and the another book you can consider is the Giras on PM motor technology. Okay. This again is a very fairly recent book. Then I think Wong, as I told you, is one which who has compiled on MATLAB Simulink. Nowadays, MATLAB Simulink has become a very useful tool for any simulation work. Okay. So, I want you to look at the techniques presented there. So, then there is a Kenjo stepping motors and microprocessor applications control, that is again a stepper motor book. So, there is one Russian book, old one, Armensky and Fock, it is a very old book. Then recently Ramakrishnan has written a book on switched reluctance motors, this is also a good book, and of course remaining things you have to pad up with some research papers and so on. So, these are some of the references, okay, which you need to know. Okay. And as I have mentioned some to you, this your broadly your effort 40% reflected in your final examination, 30% in your intermediate examinations, okay, minor tests. Then we would expect you to do a small project and make a seminar presentation on the project. So, I think slowly we will assign the project, so you can start working on this, right, and then with some assignments. Okay. Then each one of you will prepare one notes, one lecture, so that becomes a useful compiled materials for this. Okay. So, this is basically a reflection of your efforts. Okay. Now, just to give a little introduction in the about how important it is. If you look at in the world about if you take up machines with less than 375 watts, okay. So, 375 watt is how many horsepower? Okay. 0.05, 0.5 horsepower, okay, and they consume about 25% of production value of electrical machines in industrial world are small machines. So, if you say certain X is the total rupees or dollars worldwide, so 25.25 X is the value of these small machines. So, they are not insignificant, is it okay, right. So, if the if these countries produce this, of course now it is under globalization, there are a lot of shift of the manufacturing from these places, etc. Okay. And they are mass produced and high level of automation, okay. And the small and special machines comprise the bulk of automation control systems in today's scenario. So, wherever you have automation control systems, they are used, right. And I say starting from position sensors, actuators, servo mechanisms, and control system would be effective, because for all the control systems these machines are used wherever you want to control things. Okay. They also find important role in various applications like household to spacecraft, etc. Okay. Then just to give another example, step motor production in Japan, I think this is in 1982 it was 8 million, in 1988 it became 80 million. So, tenfold increase of step motor production now also, because they are used in multifarious type of applications. And for example, if you look at the number of industries, just in Japan and USA together, there are more than 100 firms which make machines which are turnover of 200 to 2000 3000 billion. Okay. So, that is the order of the industry which are there. So, there will be need of manpower who need to understand, design, develop, improve, control, market, all these things. So, that is why how the importance of this subject. Okay. Now, so now the if you classify them in a different way, these special machines can be classified as DC machines, AC synchronous machines, AC asynchronous machines, stepper motors, switched reluctance motors, disc or printed circuit motors or linear motors. Broadly I can classify them like this, okay, now, right. So, we can study them in this under these broad classifications. Okay. And what are these DC motors? DC motors could be wound field motors, right, conventional, permanent magnet motors, again DC motor, permanent magnet motors, then hybrid motors. You can have both wound field and PM, both of them may be there, okay, this hybrid motors. Or you can have brushless motor, as I told you. Brushless motor is permanent magnet, you put it in the rotor, and the stator you do the switching appropriately. So, it becomes brushless. And of course, there are servo motors. Servo motors are the torque producing motors, right. They are servo mode, okay. Unlike the conventional motor which are power producing, there are power producing and torque producing, okay. Then there are also micro motors which are very small ones. Well, the DC generators have very limited applications, maybe automobiles and some of these things, okay. Yeah, okay. I think we will I will just take 1 minute on it. So, we have synchronous motors which you know, wound field motors, permanent magnet motors, reluctance motors, hysteresis motors, eddy current motors. These are the classifications of this. On synchronous generators, we have wound field grid connected generators, permanent magnet generators or self excited generators. Okay. So, these are the ones like automobiles and so on. Okay. And AC asynchronous machines, you have 3 phase doubly fed, squirrel cage, and 3 phase generators you have squirrel cage, doubly fed, okay, and self excited induction generators. Okay. So, these are the classifications, okay, which we can see. And okay, I think I will repeat it in the, perhaps I have to do it again in the next lectures. We are almost coming to the close of this time. So, next class we will take it further about broad introductions before I take it to specific machines. Okay. We will close it here now.